Yeah, I have already started. Is the screen visible now?
Yes, sir.
Okay, let us start. I think open type of feed water heater, what you have discussed in the last semester. And I think I have discussed about the deaerator also, correct?
Yes, sir.
So which is also known as the deaerator. And deaerator, I have mentioned about the its working principle. How it is working?
No, sir.
Hmm?
No, sir.
No, okay. This is called the boiler feed pump. This is the storage tank. And this is the dome-like structure is there where you can find that there is a small vent is there at the top. And this is the line through which you can find that the feed water is coming. And feed water is coming, maybe feed water is coming from, okay, let me take this way. It is coming from the condenser, or maybe it is coming from the condensate extraction pump. And along with this, you can find also there is the extracted steam from turbine. Right, so the steam is coming here, and there are small nozzles are there. You can find that the nozzles are there, so the steams are moving in the upward directions. Okay, and on the other hand, also in the feed water line, also this is coming in. There are also small nozzles are there, so water is falling down, and whenever the steam is moving up and water is coming down, why the nozzle is placed? Because as we all know that the nozzles are placed because it is increasing the surface area, because in a small droplet form it is going to spread it, and the steam as it is density is low, it is trying to move in the upward direction, and whereas the water is coming sprinkled down, so there will be a mixing is taking place in between the water and the steam. So whenever the steam and water is goes to be mixed up, so in the feed water, if it is carrying any air, so what it will do? So its density will be reduced in the presence of the steam. Whenever it is come in contact with the steam, so the air which is passing through the feed water, so it is being means the density will be reduced and it is being lighter. So it is trying to move in the upward direction. So air will come down, and there is a mixing of hot water, or maybe the steam along with the water will mix together, and water will fall down and it will store here. So you can find that the hot feed water, so which will be stored at the bottom. So with the help of the boiler feed pump, it is being supplied. Okay, so it goes maybe it will move toward the again boiler side. It will move in this direction. So hope it is understood that why I mean how it is working, the deaerator, how the air will be removed.
Sir, please explain one.
Sir, please explain again.
Okay, so this is the top line is the feed water line. So I think you can remember. Let me draw the diagram here. So this is the flow diagram. So here you can find that this is the condensate extraction pump is there, and this is the deaerator, or maybe open feed water heater. So the steam will be extracted here. All right. So both are mixing. So here we can find that this is the boiler feed pump, and this will go to the boiler drum. So this is the boiler. This is the steam turbine. This is the generator, condenser, cooling water in, cooling water out. Okay, so here we can write this way. So this is number 1, this is number 2, this is number 3, 4, 5, 6 and 7. So what is this point number? What is this line? This number?
Sir, 5.
It is 5.
5, 5.
Okay. So this is the 5 number. And this is other side?
2.
It is number 2. And what is the bottom line?
6.
6.
No,
6.
7.
Yes, 6.
Yeah, that is 6 and this is 7. Yes, sir.
7. All right. Now you can match it.
Yes,
I
sir,
think
same.
if you match this both the figure together, so what I am going to do, so these portions I am trying to elaborate.
All right, sir.
Okay, so it is looking like this.
Yes, sir.
So here you can find that it is a dome-like structure is there at the top. So this is the deaerator portions, you can find it. Okay, at the bottom, sorry, it is a storage tank is there at the bottom. So there is a dome. So the feed water, it is coming on the top side, and this is carrying some nozzles in between in the tube line. So the water will fall down, and whereas the extractor steam line is coming from the bottom, and it is also having the nozzles. So the steam, as the density is low, it is trying to move in the upward direction. So the feed water and the steam, whenever it is going to mix together, so feed water is carrying what? Some amount of
Here.
air also it is carrying. Okay, so air, and whenever air is come in contact with the steam, so air will be lighter, becoming, already is lighter, it is becoming lighter, it is moving in the upward direction, and through the vent it will come out. And now whenever there is the exchange of heat between the steam and the feed water, it is being heated up. So that's why you can find that it is heating is taking place here. So deaerator, and finally it is a hot water will come down and it will be stored in the storage tank. So with the help of the boiler feed pump, it will be taken and send it to where? Where it will move?
To boiler.
To boiler. It goes to the boiler.
Boiler.
Okay. Now is it understood?
Yes, sir.
Yes, sir. Now it is.
Okay.
In this case, sir, some amount
Yes.
of steam may also get out from the vent.
Yeah. So it is called the evaporation loss.
Okay.
So evaporation loss means you can find that along with the air. So you can write it along with air, some quantity of steam may lost from deaerator. All right. So you can minimize this one, but it cannot be abolished completely. So some amount will definitely come out, but not that much. Not that much.
Yes, sir.
Okay. So whenever it will come out also, maybe whenever it is hitting the nozzle, so maybe it will hitting down and some amount will again fall down also. But there is always a sound is coming. Whenever you can see it, there is a hissing noise will come in this case. Because at a high velocity, whenever it is coming out, some noise will come out from the deaerator.
Yes, sir.
All right. Now, one more questions also. Generally, I used to ask the questions. Deaerator is always placed, or maybe you can write like this. Shall I erase this portion? This one?
Which one, sir?
Evaporation loss. Have you written?
Yes, 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 yes.
Yes, sir.
Okay. You can write this way also. So you can the deaerator, or sometimes we may write DA. So the deaerator is placed at the highest level of turbine floor. So in the turbine floor, it is always it is placing at a higher level. Why? Yes, anyone?
Hmm.
Can you guess it?
No, sir.
Anyone can? No one can guess it. Okay. So now I can give you a hint. It is related to pump. Which pump? BFP. Now I think you have heard the term in pump. There is a term is there which is called the cavitation loss.
Yes, sir. Yes, sir.
What is that one?
Sir, cavitation is a low pressure phenomenon
Yeah.
in which if the pressure inside the pressure inside any means the substance, if it goes beyond
Not beyond, below.
below its
Sir, if it goes
capacity,
below vapor pressure,
Yeah, very
then
good. Yes.
then
bubble will
bubbles
start
will start
forming
forming
and
and
Yes.
spitting will
Bubble will
start happening.
start forming and there will be a loss is taking place, which is known as the cavitation loss, which is not desirable at all.
So it is
So I
placed
Yes,
at
sir.
think
the
This is
top, maybe. So it is placed at the top, maybe because the feed water heater, as it will fall with the gravity. So
no,
due
not
to
only
height,
gravity.
so
What is
it will
happening
fall.
in this case?
Yes,
What
sir.
we'll do? So this cavitation loss, maybe let me take this. Cavitation loss can be minimized by what? So it
Increasing
can
pressure.
be
pressure
managed
should not
by
fall at any point of
high
time below vapor pressure.
NPSH. I think you have heard the term. Net positive suction head.
yes, sir.
Is it not? What is
Yes,
NPSH? Net positive suction head. So what we'll do, the suction side of the pump, if it will be increased, means in this case the pressure will be raised and it will be above the vapor pressure. So in that case, obviously, as the pressure is high in this case in the suction level, so definitely as it is not goes below, so in that case no bubble will be created in this case. Is it not? NPSH, net positive suction head.
yes, sir.
So NPSH, how you can create more? So the if the deaerator is placed at a high level and if the pump is placed in the ground level, so obviously the height will be very high at the suction side.
Yes, sir.
So that's why to enhancing this level or to increase the value of the NPSH of the pump, boiler feed pump, we are always placing the deaerator at a highest level. So of course it is not as high as the boiler drum. So the level should be, boiler drum is always at the highest level. But in the turbine floor, you can find that there are different equipments are there, condenser is there, the different heaters are there. But among all the heaters, deaerator is always placed at the top level. Okay, is it clear?
Yes, sir.
Or is there any
Yes,
confusion
sir.
among any one of you? You can ask me, then I can again explain, or if it is clear, then I shall move forward.
Clear, sir.
Okay, fine.
Please explain once more.
Once more. Now
Yes.
you tell me what is actually the cavitation loss, how it is created. Whenever the pressure within the component, if it is below its vapor pressure, or bubble pressure, not vapor, bubble pressure in this case, or vapor also you can say. So what it will do, it will form the bubble.
Yes, sir.
So if the bubble will be created, so definitely there will be losses are there in the cavitation. So
Yes, sir. Spitting will start occurring.
yes, splittings and many things are being happen in this case. To overcome this problem, what you can do? At the suction side, we are always enhancing the suction pressure head. And how it will be possible? Suction means definitely what you can do. Maybe you can put a pump at the very lower level, or maybe if
Yes,
the
sir.
pump is at the ground level, so then definitely the components from where the water will be sucked, that will be placed at the higher level.
Yes, sir.
So in that case, if you consider that one, because we cannot put the deaerator below the ground, correct? So if it is in the ground level, so definitely the suction rate can be enhanced if the deaerator is placed at a higher level.
Yes, sir. Obviously.
And that's why the deaerator will be placed at the higher level of the highest level of the turbine equipment. So whatever may be the connected with the turbines, whatever is there. So that's why I'm telling one term I have used it is not definitely as high as the boiler drum. So boiler drum always is placed at the highest level. But in the turbine floor, whatever may be the equipments, turbine level means what? The deaerator, the heaters are there, closed type, open type, and the condenser is there, the pumps are there, condenser extraction pump, boiler feed pumps. Okay, so whatever are there, so among which you can find that the deaerator is always placed at the highest level.
Yes, sir.
Clear?
Yes, sir.
Okay. So then let me move to the, because I think I have explained the deaerator's functioning. So you please read it once again. If there is any confusion, we again further discuss about this one. Now, in the open type of feed water heater, I think I am not going to spend more time. Open feed water heater. This is a very simple one. So you know that how to calculate the value of the M. So it is, you can consider this is 1 kg and extraction is m kg. So how much is moving here? 1 minus
m.
m kg, and that is also passing through 1 minus m kg.
Yes, sir.
And then how much is moving here through this boiler feed pump? This is 1 kg.
1.
Yes. So boiler, this is steam turbine, this is condenser, it is open feed water heater, this is condensate extraction pump, and this is boiler feed pump. Okay. So
Yes, sir.
how to calculate the M? Already we know that. So energy balance.
Yes, sir.
Energy balance
By the point
across
label
open feed water heater. So you can write summations of all energy in. That should be equal to summations of all energy out.
Okay,
Yes.
sir.
What is energy in this case?
mH2 plus 1 minus
Yes, here please
mH5.
note it down. This is 1. I think this is 2, 3, 4, 5, 6, 7. So M into H2
H2
plus
plus
1 minus m into
1
H5
minus M into H5
equals to H6.
5.
is equal to 1 into H6. 1 kg goes out. So M should be equal to, it should be equal to H6
Minus H5.
minus H5 divided by H2 minus H5.
H5.
Correct?
Hmm.
Alright. So this is the M. So what is Q1? How much heat will be added in the boiler? Yes, if you plot the diagram. Let me draw the diagram somewhere. Yes, Excel.
H1 minus H7 into 1 kg.
Yes, 1 minute.
H1 minus 7.
So maybe it will come in here. One, two, three, 4, 5, 6, 7. Take this diagram.
H1 7.
1 kg, m kg, minus m kg. Yes, here is, this is Q1. This portion is Q2. And this is the turbine work. So Q1 is equal to how much?
H1 minus
H1 minus H7 into 1 kg.
H1 minus H7. It is without, if it is without regeneration, it should be how much? H1 minus H5? It is supposed to be?
Yes, sir.
If it is no heater, if it is placed, then it should be H1 minus H5 because it will
Yes,
be
sir.
coming here. So whether the feed water temperature has been raised or not.
Yes, sir.
So already you know that if you compare this one with the earlier condition, regenerations with hollow turbine. So you can remember that in that case, feed water temperature is goes to increase. All right.
Yes, sir.
So here also you can find that instead of 5, it is becoming 7. So that means in this case, the heat addition is H1 minus H7, not H1 minus H5. So the heat additions in the boiler is goes to reduce. So less amount of or less quantity of heat is required to convert water into steam. Is it not?
Sir, please repeat this statement.
Instead of, if it is not regeneration, so you can find Q1 with regeneration and Q1 without regeneration. How much it is? H1 minus H5. So in which case the heat requirement is less?
In first case.
Yes. So that's why I mean to say that in this case regeneration is reduced. But one answer I think we did it. The boiler size is more.
Yes, sir.
Why? That also I have explained. To have the same work
Okay.
done, mass flow rate of the steam will be more in this case.
Yes, sir. Yes, sir.
Okay. So that's why you can find that in this case heat requirement to convert water or feed water into steam reduces. Okay,
Yes, sir.
but boiler size will be increased as for same turbine work. So that means in this case mass of steam flow rate into what you can write, it is H1 minus H7, that should be equal to Q1. So it is reduced, H1 minus H7, as it is reduced, so mass flow rate of steam will be increased.
Yes, sir.
Better to not this one, you write it this one, or maybe you can write this way also, work done also, that way also you can write down. So for same work done, H1 minus H2 and plus H2 minus H3. So in this case also you can find that the mass flow rate of steam is also necessary to be increased.
Yes, sir.
Sir, again explain that why this boiler size is more.
Boiler size is more, just you see that for the same heat input. Okay, but instead of this as for same turbine work, or maybe you can say for the same heat input. For same heat input, how much it is? Q1 is equal to what in this case? MS into H1 minus H7.
Yes, sir.
Correct. Now H1 minus H7 is reduced, is it not? Because you can find that without regeneration it is H1 minus H5. Now it is becoming H1 minus H7. So obviously this value is goes to reduce. So that means what's about the mass flow rate of the steam for the same Q1?
Must be more.
See, in this case Q1 is per kg. If I am considering not per kg, it is suppose it is kilojoule. So in that case for the same heat input, so H1 minus H7 is, if it is reduced, then what's about the mass flow rate of steam?
Must
More.
be
More.
Increase.
So more means what? What's about the boiler size?
more.
Increase.
So boiler size is increased. Okay.
Hmm.
Is it clear?
Yes, sir.
Okay, fine. So shall I erase this portion?
Okay, sir.
So better I erase this portion. Okay. So you can write it this way also. Q1 is equal to H1 minus H7. What is Q2? Heat rejection.
Yes, sir. H3
How much?
minus H4.
H3 minus H4 into 1 minus M.
Yes, mass flow rate is also important. 1 minus M into H3 minus H4. Okay. So what is turbine work? So this is 1 kg and this is 1 minus M kg.
H1 minus H2 into
1 into H1 minus H2
plus 1 minus M into H2 minus H3.
1 minus M into
H2 minus H3.
H2 minus H3. What is WP?
1 minus M into.
So WP means WCEP plus W boiler feed pump. So what is CEP? So this part is WCEP
Yes, sir.
and this is W boiler feed pump. So we can write it down. It is equal to how much? 1 minus M into
H5 minus H4.
H5 minus H4 plus 1 into
H7 minus H6.
H7 minus H6. Good. So what is the overall efficiency? 1 minus Q2 by Q1, and that should be equal to written as WT minus WP by Q1.
Yes.
All right.
Yes, sir.
Okay. So this is open type of heat water heater. So shall I move to the next part? Have you written? Please
Yes,
write
sir.
it down, or else I shall move.
Sir, 1 minute.
Yes.
1 minute.
Yes. Complete it. As others, you can understand or not? I cannot.
Yes, sir.
I cannot able to hear many voices, so that's why I don't know. I am confused whether other people they are feeling it is tough for them or it is okay, because then only I can be satisfied in my explanation. Otherwise, again I may change. Maybe in the other way I can try to explain it. If it is clear to all, then it's fine.
Yes, sir. Yes.
Okay. Argo, is it fine? Where is Argo?
Yes, sir. So sorry, my computer got hanged actually. That's why I couldn't reply.
What, gentleman? You're moving here and there?
No, sir.
Okay, fine. Now, what's the question I've asked? I have asked that whether it is clear to you.
Yes, sir. I said that only.
Okay, fine.
Actually,
Fine.
my computer got hanged, so I couldn't.
Okay, no problem, no problem. Okay, so shall I move then?
Sure, sir.
Okay. So let us move to the closed type of heat water heater. And closed type of heat water heater, in this case, where is the difficulty? Let me discuss. I think you also maybe try to understand what is the problem. See, I am always referring the same diagram almost. Okay, so you can find that. But in this case, as it is closed type, so they are not mixing together. You can find that it is like a cell and tube heat exchanger. So it's like a cell and tube heat exchanger. HX stands for heat exchanger. So how it looks like? So you can find that it's looking like this. Cell and tube means in this case, suppose in this case, this is a tube through which the steam is coming in, and this side, or maybe in the same side also you can find it. So the steam, and here this is a cell like structure is there. Inside this you can find that the small tubes are connected. So you can find that the tubes are connected here. All right. Now what happened in this case? So here you can say this way that the suppose in this case the feed water is coming in, and this side maybe feed water goes out, and this side steam in. So cell side means outside this the steam is coming in, and this side the condensate goes out.
Counterflow.
Yes, counterflow it is.
Yes, sir.
All right, so it is coming in and it goes this way. So you can find that the steam in this case, suppose it is coming in and it is going, it will come this way, and this side the steam is coming through these pipes or the tubes and it goes out. All right.
Yes, sir.
So it is not mixing together. So I am taking, this is the extracted steam is necessary. This is the extracted steam, or maybe it is the bleed steam. It is being bleeded from the turbine, steam turbine. So it is the boiler. So it is the generator, condenser, CEP, and then this side. So this side you can write this, or else it's not CEP. You can instead of CEP, better you write down it itself is a boiler feed pump. So here it is a boiler feed pump directly, and it goes to this side with the help of the boiler feed pump. It goes here. Now here is the question: whenever the steam is being extracted and it will release the heat, the condensate will come out. Now where the condensate will move? Where the condensate will move? It will come out. Now let me discuss, or let me tell that what is the future of this condensate. What's about this future? Where it moves? Yes, anyone? What are the possibilities?
It may mix with the river.
No, river, how it will be river? So you mean to say it will go to an, so it is, see, you know that this steam, whatever is being generated, it is from which water? It is from the DM. Means, what do you mean by DM?
Demineralized.
Yes,
Demineralized.
demineralized water. You know that the cost of the demineralized water is very high. Okay, because you have to remove all the minerals from the water. So first of all, you have to go for the water treatment, and once it will be treatment, then you have to go for the demineralizing process, and the cost of the productions of the water is quite high. So that's why you cannot waste the water. So this water, whatever is coming into the Rankine cycle circuit, this water is very costly water. So you cannot simply throw this water into the river. So what you will do? So definitely we will try to utilize this water into the cycle itself. So how it is possible? What are the possibilities?
We can send it to the boiler.
How? Because you can understand, in this case, whenever it is, see, boiler pressure is higher than this steam extraction pressure.
Yes. We can again pass it to BFP.
Again, you have to send it to the boiler feed pump. But so you want to say that you will add it here?
Or maybe we can use a dry pump.
We can
Dry pump and again.
Okay. So there are, so I understood that there are two possibilities. Either this will move in this directions or it can move into the boiler directions. So it is called the feed forward direction, correct? Or it may be feed backward.
Yes, sir.
Now, whatever the steam will be coming out and it is passing, so whatever pressure is the same as the steam turbine pressure, extraction pressure. All right. Now there are one possibility is that, so in the condenser, you can find that there is a small chamber is there, like a storage tank. It is called the hot oil. It's like a room. Suppose you are having suppose this is the condenser. Okay. So in the condenser, you can find that the steam is maybe from the turbine. You can find that the steam is coming here. It is, sorry, it's not here. Just a little bit change I can make this way. Hot well. This is known as the hot well. Maybe you can find that the turbine is there. So the extraction, whatever is there, it is coming here. All right. So the steam is coming here. Now there is a, so once it will be cooled down, so it is being condensed, because again also you can find that there is this phenomenon is there. No? It is cooling water in, cooling water out. So whatever is the condensate, it will be stored at the bottom. So it is known as the hot oil, like a storage tank at the bottom. So what we will do, these portions will be, so I am putting in a dotted line because it is irreversible process, it will take place. So it will come back to the hot oil. Then whatever you are telling, na, correct? You already, some of you mentioned that it will be connected before the boiler feed pump. Now from the boiler feed pump, it will be connected and it will move it. Is it fine?
Yes, sir.
And it is very easy also, because steam extraction pressure is definitely more than the pressure of what? Condenser.
Yes, sir.
So automatically by the virtue of the pressure difference, it can move to the hot oil.
Yes, sir.
Or else, some of you told you want to sell the boiler. So don't be deserted. That is also possible. But as you know that the boiler pressure, this side is definitely larger than the steam extraction pressure. So what do you need to do?
Another pump. We have
so
to add.
you have to add a pump.
Dry
And
pump.
that is known as the drip pump.
Oh, sir.
With the help of the pump, you can connect it here. So there are two possibilities. So this is number one, using the drip pump, or maybe it is the number two, it will goes back to the hot well. All right.
Sir,
Yes.
sir, why are we calling a drip pump, and why are we calling that one as a feed pump? What is the difference?
Oh, I am not getting drip pump. Why it is dripping? So dripping, you know, na? Drop wise you are sending it. You are going back. You know that when the blood drip is used in our body also many times.
Yes, sir. I'm
So
getting you.
yeah, and second thing, why it is called now here. There is one more view. Actually, I am telling it very easily that it goes to the hot well. But see, this condensate is still having a high temperature. And whenever it is going to the hot well, the temperature is much lower. So shall we allow to lose the heat?
No.
So there should be some, definitely we have to think about this on what can be done. So I am going to move to the next slide to explain this one, that how can this heat will be released if it will be moving towards the hot well, how this heat will be utilized. So whether you have drawn it, is it clear? Then I shall move to the next slide. Otherwise, I shall again ready to explain once more if it is not clear to you. So what is the question I have asked? I have asked that the condensate, whatever is being generated here, we are trying to move into the hot well, but as it is carrying huge quantity of the heat, definitely we will not release the heat, or maybe we don't like to waste this heat directly sending it to the hot well. We are trying to extract some more amount of the heat from there if possible. So
when we prefer to use forward and feed backward,
it is completely depending on the company, or better to say that the industry who is making this steam turbine. So this is their trade-off. All right. So that is completely depending on them whether they will go for the feed forward. But generally, what you will do, I am going to give you the answer maybe after on the next slides. Whenever I am going to present you, I can able to give the answer that time. All right. So shall I move to the next slide?
okay, sir.
Yes, sir.
Okay. Okay, fine. Now here, first of all, you please remember, I'm going to write this one very important statement. In a power plant, there are several closed type feed water heaters and one open type of feed water heater. Okay. Now this closed type of, I have mentioned that more than one, so many feed water heaters are there. Closed type of closed feed water heaters, this may be classified into this way. Some of them are called high pressure feed water heaters, and some of them are known as low pressure feed water heaters. So can you explain that what is high pressure feed water heater and what is low pressure feed water heater?
Sir, the one which will receive the one which will
both are closed type of feed water heaters.
Okay. So, sir, I think high pressure feed water heater will increase the pressure by more amount.
The boiler pressure is more.
No, boiler. How can you change the boiler pressure? Boiler pressure is fixed for a power plant based on the generation capacity. Okay. So that means it is very clear whenever I am telling high pressure or low pressure, there should be some reference line, correct? There should be some reference point. And what is the reference point? That is called the deaerator. So if the pressure is above deaerator, this is called high pressure feed water heaters, correct? And if it is, so that means you can say it is greater than. So greater than deaerator is called the high pressure feed water heater, and this is less than deaerator is called the low pressure feed water heater. Understood? So in this case, it is less than deaerator pressure, and in this case, you can write greater than deaerator pressure, the pressures. Okay. So let me draw this way. I think it will be clear to you. So what is this one?
Aerator.
Aerator. Okay. So I am adding some closed feed water heaters are there here. Here also I am adding some more number of feed water heaters are there. This side the boiler is there. This side is the steam turbine. You can find it because different points it will be extracted. Now it will move to this side. There is a condenser. Then condenser 2, there is a pump is there, that is called CEP. And always boiler heat pump is, if deaerator is there, it must be connected after the deaerator. All right. Now tell me, which pressure which is high pressure feed water heater, which are low pressure feed water heaters?
The left one are high pressure.
Left one is high pressure. Okay.
Yes, sir.
Okay. So these are HP feed water heaters,
Absolutely.
correct? All right. So these two are the H pressure feed water, and these are low pressure feed water heaters. Okay. Now question is that start from this one. So first one. So what it will do? So what's the condensate will do? So maybe you can find that the condensate is coming here. This it is going to the next feed water heater. I am not sending it to the deaerator, correct? I am not sending it to the condenser. So what I am going to do? I am sending it to the next low pressure because this pressure is higher than the next feed water heater. So obviously the condensate of this first heater, it is higher pressure than the second one. So it will goes back to the next one. So what is it is called? So it will go here. Now this one, this portions I am sending it to her deaerator. So now this will go to the next feed water heater. This will go to the next feed water heater. All right. So whenever it is goes from first to second, higher to lower, lower to next lower, next to next lower. So it is called cascading. What it is called?
Cascading.
Cascading. So that means there is one possibility is that it is moving, it is cascading, means first one go to the next low pressure, next to next, next to next. If it will goes on moving, so it is called the cascading. And where the last one will go? Where the last one will go?
Condenser.
It either it goes to condenser or else what you can do?
After the condenser. Just after.
No.
Okay, okay. Drip.
I am using a drip pump and connected here.
Yeah.
Okay.
Yes.
So it is everything. So some of you are asking that which one is the better. So it is completely, it is the trade-off of the company. So here, maybe this company, so what he can do? So in the last one, it is goes to the last one. Instead of this, what he can do? He can put a drip pump here and he can add it here. That is also possible. Another drip pump. So it is depending on what? It is completely depending on the company. So they will do the calculations and they will say that in which combinations is giving us the best efficiency or higher efficiency. All right. So that means in this case, you can write this is suppose M1, this is M2, this is M3, M4, M5, M6. So how much will move to the condenser? How much? It is 1 kg. How much will go to the condenser?
1 minus M1.
1 minus M1 minus M2 minus M3 minus M4 minus M5. That will go to the condenser. This is the boiler. Is it clear or not?
Sorry, please explain the cascading process in short.
Cascading means what? cascading means first high pressure to the next lower, next to next. If it will go on, so you are going to cascade it. So you are going to cut it and it will send it to the next one. So it is no need to any boiler pump to put in the forward direction. Just by the virtue of the pressure difference, it will move to the lower pressure, next lower pressure, because this pressure is higher. So this first heater is pressure is higher than the second one. So automatically by virtue of the pressure difference, it can move to the next one. So this one will go to the automatically go to the deaerator by the virtue of the pressure difference. Now deaerator, it will not go back because it is mixing together. So it is no need to again send back because condensate is being mixed with the extracted steam. But here in the low pressure side, first low pressure heat water heater, it will send it to the next one. So next one will go to the next one like this. It will keep on moving, and that's why this process is called the cascading process. You are going to curtail this one by one. You have to connect it. And yes,
Yes.
is it clear?
So finally, it will be ending up at M6 here.
Finally, last low pressure heater, you have to decide it. Maybe it will. You can use a drip pump, or maybe you can send it directly to her. Deaerator, hotel, you can send it. That is also possible. Okay or not?
Yes, sir.
Okay.
But why we are using this cascading process?
Now, I am telling it is completely the trade-off. So these are the two ways what you will do with the condensate. So one is you can use. So let me write it down. So shall I move to the next slide?
Yes, sir.
Yes, sir.
Yeah. So let me write it down so it will be clear. So I can write like this: disposal of condensate of extracted steam. What we'll do? So there are three possibilities are there. Number one, all condensate, or maybe it is sometimes called the drip. All condensate or drip to condenser. So what is the meaning of this one? What it will do in this case?
Sir, we are
Suppose-
sending it
Yes.
to the hot.
So what we are doing? Suppose this is M1 is coming. Suppose this in this case M2 is coming. Suppose in this case M3 is coming. Maybe here we can find that. What is this one?
hot well.
No. What is this one?
So that is condenser.
Condenser. So there is a hot oil is there. So what it will do? I'm sending it to where?
To the condenser or hot well.
Yes. Condenser hot well. So where it will move? All are moving in which direction?
Backward.
Yes.
Feed
So all will
backward.
move like this. And why I am putting the dotted line?
Because it is irreversible.
Actually, we are using a steam trap here. So it is already you know that steam trap, if it is being used in the process, this is called the isenthalpic process, correct?
Yes, sir.
It is irreversible process, you know it. So what we will do in this case? Let me draw the diagram. How the TS diagram is looking like. How many extractions are there? 1, 2, 3, correct? This is the fourth one. So this is 1 kg. This is M1 kg. This is M2 kg. This is M3 kg. And what is the last one in the condenser?
1 minus M1, M2, M3.
Okay.
Yes,
So
sir.
what it will do? First extraction, where it will come? A dotted line. Where it will come? Coming to where? Condenser.
Condenser.
Second one, where it will come?
Condenser.
Condenser. Where it will come?
Condenser.
Third one, condenser. Okay. So this is the diagram. You can find it in this case. So you can write it down. It is the simplest arrangement available with the condensate or maybe the drip. It is also called drip. Okay. And which is, what is the condition? Which is saturated, which is at saturated temperature, which is a saturated temperature is sent to condenser hot well. Clear?
Yes, sir.
Okay. Now the next one. So have you written? So please write it down. Then I shall move to the next slide.
All right.
Okay. So please stop me whenever it will be 45. Okay, you are having class, I know. For 45. So before and you ask me because I have to take the attendance. So what is the time right now?
25.
25.
Fine. Ajay, what's about the other boys, my students?
What,
Whether you
sir?
are understanding?
Yeah.
Yes, sir.
Because I can see few voices are coming actually.
Yes, sir.
Okay.
Yes, sir.
Yes.
Thank you. So here also you can find that this is also steam trap is there. That's why the enthalpy C, what you can write, maybe suppose this is point number A and point number B. So what you can write? H is equal to HB. Suppose this is C, this is D. So HC is equal to HD. This is E, this is F. So HE is equal to HM. All are isenthalpic processes. Isenthalpic processes. Okay, so next one. So now what are the next possibility? So you can write it
Sir,
down.
can you please show the previous page, sir?
Yeah.
Previous page once more.
So that's why I'm asking whether it is over or not. You tell me so that I can move to the next slide. It is called steam trap. Please note it down. If some steam is at all present, it will trap it. It will remove it. Okay. So it will allow only the water to pass through. Over.
Yes, sir.
Okay. Okay. Disposal of condensate or the drip by putting drip pump. So this is the next possibility. So I'm going to explain it. So in the same way I shall do it. Suppose there are three condensates are coming. So three extraction points are there. It is M1. M1 means all are coming from where? Which I have not shown it. Which all are coming from turbine actually. All right. Now what are the possibilities are there? Now drip pump means what it will do? What do we have to do? Okay, this condensate will go to. So this is the possibility. Okay.
Yes, sir.
Okay.
Yes, sir.
So how it looks like? Maybe this is the first extraction, this is the second extraction, this is the third extraction, and this is the last one. So now last one, it is boiler feed pump. So directly it is sending it to the boiler. Okay. So directly it is boiler feed pump means it will go to this one. Now what it will do? Now this one will send it to where? There is one drip pump. This is another drip pump, and this is another drip pump. You can find everywhere there is a drip pump is connected.
Yes, sir.
Clear? Or else maybe it will be little bit confusing. Let me write in a better fashion. So here is one pump. There is another pump. This is another pump. So it is this side. These are the directions. Okay. So this is for what? Feed pump 1. This is what?
Drip 2.
Feed pump 2. All right. And this is
Drip pump 3.
and what is this one?
Boiler feed pump.
Yes.
Yep.
This is boiler feed pump BFP. Okay.
Yes, sir.
Now what's about this scenario? Please note it down. What are the features of this one? It is little bit complex nature, correct? So complexity is complexity in operation. We can find it. And one more point is also you should remember. If any drip pump fails, suppose if it is not working, so there is a chances of flooding of drip in the heater may cause water to flow to turbine, to flow water to flow into in the turbine.
Can you repeat the second point once more?
Yes. If any drip pump fails, flooding, FLWDING, flooding of drip in the heater may cause water to flow in the turbine, to flow into the turbine. So there is a fluctuations of pressure will be created in this case. So there is a pressure fluctuations will be occurred in this case. Shall I repeat? If any drip pump fails, flooding of drip in the heater may cause water to flow in the turbine. So which creates the pressure fluctuation in the turbine, which creates the pressure fluctuations in the turbine. Okay.
So what actually happens? It backflows into the turbine.
Backflow support, this is not working. So what it will do? If it is not working means obviously the steam will not come here. So automatically what it will flood means it will increase the level and ultimately it will go back to where? Steam turbine. So see, so this is, see, it is supposed, the pressure, it is supposed to come down. So pressure is being reduced here. So but it is not creating that way. So the pressure fluctuation in the turbine will take place in this case. So there is a not a maintaining the pressure in this case in the turbine. So it is very difficult in this case. So it will be filled up. So completely, instead of this, it is coming in the forward direction. It is already flooded. So that means the total systems will be collapsed in this case. Okay. Shall I go to the next slide?
Yes, sir.
Others completed?
Yes, sir.
Okay. Now what is the third possibility? Whatever I mentioned, what is the third one?
Cascading.
Yes. Cascading of drip or maybe the condensate. So what is the possibility in this case? M1, M2, M3. So where it will go? Okay. So this will go to okay. And maybe this will go to so what is this one? First one will go to second one will go to third like this. What is this process is called?
Cascading.
Cascading. So how the TS diagram is looking like? This is the first extraction, second extraction, third extraction, and this is the condenser. So condenser already we know that this is connected with the directly it is the boiler feed pump. Now what it will do? So this will come where? Here. This will come here and this will come where? This one. So this is the dotted line. Okay.
Yes, sir.
So this is happened in this case. So this is, it is the first cascading, the second cascading. Huh? So here it is first cascading. This is the second cascading. This is the third cascading. All right. Okay. Clear?
Yes, sir.
So it is coming from where? Condensate line to, it is coming to the next level. So it is falling down. So again it is coming here. This will come here. Yeah, plus, yes, please, some noise is coming. Someone's mic is unmuted. Please mute yourself.
And these lines are also isenthalpic lines, right?
It's an isenthalpic line, correct. It is a dotted line like this.
Okay, sir.
Like this, okay. These are all dotted line.
In the first process also you mentioned about this cascading, no?
First process is not cascading. Yeah, first process all, no, not cascading. All drip goes to condenser.
Oh.
Cascading means first to second, second to third, like this. It is cascading.
Okay, sir, got it. Just confused.
Okay. So I think you got the idea. Now in actual power plant, it is the combination of all this. It is totally so I think in the next day I will explain, or maybe I am going to give you the problem where you can find it, that how to calculate this one. So maybe, so what I suggest you, please go through the book. Okay. And I think the day after tomorrow you are having a class. So during that time I shall explain in further about this one. So I shall go for some numericals also. And in that case, it will be clear that how the calculation is being made. I think one more thing is also, I think it is necessary for us to decide about the exam. So your exam is from 7th, your CA1.
Yes.
7 to 12.
Yes, sir. 5 days. 11, I think.
7 to 11. Okay. So when is it possible to give the exam? You tell me. Next week I shall take an exam on Monday. I shall take a class on Monday. So it will be good if it is. I think if it is, the class will be off in that case.
Sir, I don't think. Last year also class happened.
Class happened.
So during CA1 it happened, but during CA2 it did not happen.
Okay, okay, then no problem. So then, when is it possible? Which day?
We will discuss and
We'll discuss and tell you.
Actually, one more point is very clear, because I shall take exam for 50%. So that means out of 15, maybe 7.5 is from my side. But I don't know about the other part.
he has not done any class with us.
That's why, what is the decision you have taken? Have you approached to the HOD?
Yes, sir.
Huh?
Yes, sir. We had a talk with him. So he said that sir, not to worry about that. The department will take care.
Okay, all right. Now, but you have given any official mail?
Sir, we have talked to him via call only.
Now, call is not giving any record actually. What I want that you please do all the way, because my part I shall complete it. But ultimately the examinations will be hampered, because I everything will be in 50%.
Yes, sir. We'll mail him once again.
So whatever you will do, you do in the proper fashion.
Yes.
See, my part I shall complete it, and definitely I shall also inform him officially that my portions I have covered, and I shall go for the exams out of 50%. Okay, so I cannot make my portion double.
Yes, sir.
It is not a good way also. Okay, so because I am putting my effort, so that at least 50% efforts, my portion it should be, so other person will take the other part. Okay, so I think what is the time?
Sir, it's
almost
4:43.
Just give me 2 minutes time. Is there any confusion, any question?
No, sir.
No, sir.
Okay, then fine. Just 1 minute. Let me take the attendance. So just